Welcome back to the deep dive. Today we're embarking on a rather unusual expedition, I guess you could say.
Yeah.
Where are we headed? Well, it takes us into a world typically pretty far removed from, the blinking cursor and the command line. We're going to the zoo.
Ah, the zoo.
But this isn't just any zoo visit. It's a trip seen through this incredibly specific lens, the lens of a programmer.
Right. Okay, that's interesting. We've got this stack of sources here, bits from things like Debugging the Zoo, a programmer's guide, also some notes from a humorous deep dive guide, and then these observations filed under zoo trip developers.
Yeah, and they really paint this picture, don't they, of a mind that's used to logic and structure, grappling with, well, the sort of messy organic complexity of nature, and doing it using the tools it knows best, code concepts.
Exactly. So picture this.
Yeah.
You're a developer, right? Your whole world is logic gates, syntax, functions, debugging.
Uh-huh. Orderly, mostly.
Mostly. And you live in the city. Your main encounters with nature are pigeons, maybe some rats.
The usual urban wildlife.
Yeah, right. And now, first time ever, you're at a zoo, standing in front of, say, a gorilla. And it doesn't exactly have a well-documented API, does it?
Haha. No get banana function readily available. It's a completely different kind of system. One where, behavior trees are biological instincts, not something you code in Unreal Engine.
And inheritance means, well, biological classification species, genus, family, not just extending a class in Java or Python.
So the standard zoo experience, those descriptive signs, often quite beautifully written.
Yeah, the paragraphs about habitat, diet, social structure.
Our listener, the developer in the sources, finds them just too long to read.
Which sounds dismissive, but it's probably more about how their brain is wired.
Yeah.
Right? They're optimized for processing structured data, not necessarily narrative prose.
Exactly. It's an information parsing preference. So what do? They ask for the information in a format they can parse easily.
They basically request a translation layer. Give me the context for these animals, they say, in a more programming way. Not actual lines of code, mind you, but more structured. Direct text, clear declarations, functions, that kind of thing.
And this is where our deep dive really kicks off. What actually happens when these structured, logical programming concepts collide with the wild, sometimes chaotic reality of living creatures?
It throws up some fascinating questions we need to unpack from these sources. Like, first off, why is this whole thing looking at a zoo through code actually kind of funny?
Yeah, there's definitely humor there. And does it maybe, highlight a sort of weak link to the natural world for people really deep in tech? But at the same time, maybe an incredibly strong link to their modern digital lives?
That's a great point. And it makes you think about complexity itself. Is the traditional wordy description of an animal inherently simpler? Or is the code style breakdown simpler if you're wired that way? Which one is actually more complicated?
And maybe the biggest question, the one that kind of ripples out from this, does seeing the world this way, applying these programming ideas so naturally, suggest that coding logic, the fundamental thinking behind it, isn't as alien or complex as some people think?
Interesting. Could it be more intuitive?
Maybe. Okay, let's fire up the metaphorical IDE, unpack these sources, and try to debug this whole zoo trip.
Sounds good. Where do we start?
Well, the source material drops us right in. We've got our listener, the developer, at the zoo. It's a nice day. They're with their girlfriend. And crucially, they explicitly state, "This is my first time ever at a zoo."
That detail really is key, isn't it? It sets the stage immediately. The natural world beyond pigeons and rats is basically uncharted territory for them. They're mental models for understanding complex systems. They were built coding, not climbing trees.
Right. And their immediate reaction to the standard zoo infoplex, too long to read here, it just bounces off.
It's not just being impatient, I think. It really speaks to that cognitive preference. Developers are used to docs, right? Structured, keyword-rich, efficient, API references, error logs.
Yeah, long paragraphs of flowing prose can feel like verbose logging you have to sift through. Unnecessary data overhead.
So their request for a solution is super specific and really revealing. They want the animal context in a more programming way, not in code, just more structured and direct text with clear declarations and functions.
They're literally asking for a translation. Map the biological domain onto the computational domain they live in. It's not just for kicks. It suggests this is how their brain organizes information fundamentally.
It's their cognitive toolkit. It's built on objects, attributes, methods, inheritance. That's how they make sense of complexity.
So the first test case, the gorilla. And the response they get in the source material, it's just a brilliant execution of that request.
It starts right at the top, the absolute basic. Class, gorilla.
Like defining the blueprint in object-oriented programming. This is the fundamental type of thing we're dealing with.
Exactly. Then, inherits. Primate, mammal, animal.
Which is just perfect, right? It maps biological classification directly onto OOP inheritance. A gorilla is a primate, which is a mammal, which is an animal.
It shows that biological hierarchy, that tree of life built on shared traits,
Yeah.
follows the same kind of structural logic you use to build software.
Yeah.
You know, if the primate class has a grasp method.
Then the gorilla class automatically gets it, unless it needs its own specific gorilla version, an override. It makes that evolutionary relatedness feel concrete, almost functional.
Maybe more so than just a branching diagram, especially for someone who thinks in terms of class hierarchies already.
Right. Then comes attributes. These are the properties listed. Species, diet, social structure, leader type, the silverback, weight, lifespan.
In code, these are the variables, the state of an object. For a specific gorilla instance, these would hold its values. For the class gorilla, they define the kinds of data all gorillas have.
The data fields that define what a gorilla is, and then, naturally, key methods.
The functions, what the gorilla object can do, communicate, move, rest, care for young, display strength. These are its capabilities, its actions.
And finally, there's a notes section. Things like intelligence level, endangered status, general temperament calm, apparently.
Like code comments, right? Important context, flags, maybe non-functional requirements that don't fit neatly as data or actions.
What strikes me is how seamlessly it all fits. Complex biology classification, traits, behaviors rendered using this logical, structured, functional framework. Programming concepts imposing order on this living thing.
It really does. And that brings us right back to those core questions we wanted to tackle. Does needing this translation suggest a kind of weak link to nature?
It seems plausible, doesn't it? The fact they had to mentally compile the gorilla through a programming filter suggests their default parser for the natural world isn't the standard biological one. They're using their developer tools.
Yeah, it implies their primary way of processing something new, even something as fundamental as an animal, is routed through their technical expertise, which, conversely, really highlights their strong link to modern life, to technology.
Their language, their preferred structure, their whole cognitive approach is shaped by their profession, by the digital world. They're literally seeing the world through code concepts.
So what about that complexity angle? Is this code style description actually simpler?
Well, the user's reaction is pretty clear. Now we understand fully. That's a direct contrast to too long to read.
So for them, yeah, this structured technical view seems undeniably simpler. It breaks the animal down into components, attributes, methods, inheritance that align perfectly with how they build and understand systems already.
It's not dumbing it down. It's presenting complex info in a format that's cognitively efficient for a programmer's brain. For someone used to class definitions, this might just be more digestible than paragraphs about social dynamics.
The structure makes it click.
Yeah.
So, okay, they've got the basic gorilla class structure down. What's next?
Well, being a developer, understanding the high-level structure isn't enough. They want to see inside the black box. They asked to open functions for these calls so we can see how they work, specifically for communicate, move, and display strength.
Ah, classic. Like double-clicking a method name in your IDE to see the implementation details. Show me the code. Or in this case, the behavioral logic.
Exactly. And the source material obliges, breaking down the internal mechanics of each function.
Okay, so how does communicate work in this model?
It lists the purpose. Sharing mood, status, warnings, then the specific behaviors. A list of actions like emit grunt, chest beat, stare, gesture. And finally, the output. What changes? Usually the troop awareness state or maybe individual relationship status variables.
So input situation, process-specific actions, output, state change. Very function-like. What about move?
Similar breakdown. Purpose, navigate, forage, escape. Behaviors, knuckle walking, climbing, sitting, carrying infants, and governed by conditions or parameters, crucially including move speed and pathfinding logic. It dissects the physical act.
And display strength. That's a complex behavior.
It gets a detailed treatment. Purpose, warn rivals, assert dominance, avoid fights. Behaviors, the chest beat, standing tall, roaring, maybe a fake charge. Then triggers, what sets it off. Threat detected. Rival proximity, troop safety concerns, and the output. Typically, conflict resolution without violence, maybe changing the rival's aggression level.
It's like a little algorithm for conflict management. Identify trigger, execute behavioral sequence, update state.
It absolutely is. Breaking down these fluid, seemingly instinctive animal behaviors into discrete steps, triggers, inputs, outputs, that's fundamentally how you approach designing algorithms or systems in software, dissecting the natural into a logical flow.
But the user isn't done with move, are they? They latch onto that move speed parameter mentioned earlier. They want to know exactly how it's calculated. They remember reading speed is low unless alarmed.
Right, they want the formula. And they get one, a quantitative model the source provides. Move speed, base speed, x state multiplier, x terrain factor.
Okay, that's straight out of game development or physics simulation. Speed isn't just fast or slow, it's calculated based on variables.
Exactly. They define base values like constants for typical and max speed. Then, lists of state multipliers. Is the gorilla relaxed? Foraging? Alarmed? Each state gets a number, a multiplier. Alarmed state equals higher speed multiplier.
Makes sense. And terrain factors too.
Yep. Flat ground, dense forest, steep slope. Climbing each terrain type gets its own multiplier that adjusts the speed.
So you could actually calculate it. They even give examples.
They do. Concrete calculations for specific scenarios, like foraging in dense forest results in this speed versus alarmed on flat terrain results in that speed. It's not just descriptive, it's defined computationally.
Wow. It's showing them how the value changes, not just that it changes. They're basically getting the pseudocode for gorilla movement speed.
Pretty much. And the source even hints at future enhancements to the model, factoring in stamina, energy cost, group movement dynamics.
Concepts you'd absolutely need for a realistic simulation or a complex game AI.
This whole deep dive into move speed just hammers home the point, doesn't it? This user finds the technical, quantitative, formula-based explanation highly understandable. Maybe more understandable than just describing how the gorilla looks when it moves fast. They want the underlying logic, the calculation.
They're dissecting biological reality using computational logic. Give me the formula, not just the feel of it.
Which brings us back again to that complexity question. They found the initial descriptions too long, but then actively sought out more detail, drilling down into method implementations and calculations.
It really suggests that for this person's way of thinking, the code style breakdown wasn't just not more complicated, it was significantly easier to grasp. It clicked with their mental models of how systems work.
Yeah, describing gorilla movement might seem simple to a biologist, but maybe breaking it down into base speed, multipliers, and factors is simpler for someone used to modeling systems numerically. Complexity isn't inherent. It's about the match between the description and the cognitive tools you bring to it.
Right. Okay, so we've seen the technical breakdown, the structured view, but you mentioned earlier, this stuff is also genuinely funny. Where does the humor come in?
Ah, yes. This is where the sources really shine. It kicks off when the user, having grasped the gorilla class, says, finally, someone that speaks in our language we understand, we have feeling that class, people around us are from different planet.
Huh. Okay, yeah, that's instantly relatable programmer humor, isn't it? That feeling of being an outsider, that your way of thinking is just different from the normies.
Totally. Feeling misunderstood by those outside the tech bubble, like you're running different operating system.
And the response in the source just leans right into it, calling them subclass, nerds understand each other. Perfect.
Then it sets up this fantastic comedic contrast. It frames the programmer's thought process as this kind of tangled, almost neurotic debugging loop. If person.behavior, not in self.expected social protocols, self.internal buffer.append.
Constantly analyzing, trying to parse unpredictable human input, logging errors when it doesn't match expectations. Yeah, that feels familiar.
Compared to this beautifully simple, almost zen-like gorilla behavior loop. If hungry, eat. If tired, nap. Else vibe.
Oh, that's brilliant. It lands because it taps into that perception of animal simplicity versus human complexity. Animals just are. They just do. Humans. Yeah. We overthink, we analyze, we get stuck in loops of...
And the punchline just seals it. Gorillas have a clean API, no bugs, respect.
Huh. Applying software engineering ideals, a clear interface, perfect reliability, elegant efficiency to a gorilla. It implies nature nailed it. Achieved this perfect, simple system that human creations, and maybe humans themselves, often fail to match.
It's funny because it's so unexpected, yet strangely fitting from that perspective. But then the user jumps in with their own contribution.
Ah, yes, the modification to the gorilla behavior tree based on careful observation. They add elif board, scratch its ass.
Which is just perfect. It's slightly awkward, undeniably true based on zoo observations, and fits perfectly within the established code structure. It feels like adding a necessary edge case or a minor feature update.
It's observational comedy framed in pseudocode.
Yeah.
And the source's reaction just amplifies it, right?
Totally. The validation. Yes, that's the most accurate gorilla behavior tree I've ever seen. Calling it the final production-ready version, listing these mock software benefits. 0 dependencies, no user input required, cross-platform compatible.
Treating this basic, slightly crude observation like it's this robust, elegant piece of software engineering. That's hilarious. It's the absurdity of applying rigorous technical praise to something so mundane and biological.
The core humor really comes from that relentless application of the logical, structured technical framework onto the messy, illogical, sometimes just plain weird realities of nature and human life.
Like that final contrast they draw. Honestly, gorillas are running the cleanest behavioral loop in the game. Meanwhile, humans are out here throwing exceptions over coffee orders.
Exactly. It's the collision. Rigorous logic meets chaotic reality. It highlights the programmer's desire for debuggable clarity and finds endless amusement in how often the real world, especially the human part of it, lacks that clarity. That's why it's funny. It's relatable if you've ever tried to impose the logic of your job onto the rest of your life and seen where it fits and where it hilariously doesn't.
Okay, so the gorilla section was rich. Does the codeZoo tour continue?
It does. The user then asks about the red lionfish things.
And does the programming analogy hold up?
Oh, yeah. Right off the bat, it's described as a deadly firewall with gorgeous UI.
Firewall for the danger, UI for the looks. Nice, I like that.
The structure follows the template. Class. Red lionfish inherits. Scorpion fish, rayfin fish, afish animal, keeping that biological to OP mapping going.
Attributes.
Attributes include color patterns, venomous spines, and critically invasive status. Key methods are things like hunt, sting, hover, and importantly, spread. And then some interesting flags, like is beautiful, is safe to touch, false, causes marine ecological disruption.
Okay, standard object description. Any other programming analogies?
Yeah, they describe a venom's effect using a term straight from gaming or maybe system modeling. It has a built-in damage over time function if you mess with them, applying a software effect pattern to biology.
Damage over time. Yeah, that fits Venom pretty well. But then there's a naming issue, right?
Exactly, a classic debugging moment based on naming. The user, seeing lionfish, asks, where is lion function if it's called lionfish?
Which, from a programmer's viewpoint, is a totally fair question. You expect names in code to mean something, to reflect function or heritage. If it's a lionfish, shouldn't it have some lion-like methods or inherit from a lion class somewhere?
Right, but the explanation clarifies this naming bug. The lion part is purely cosmetic, the flowing, mane-like fins. It's about visual styling, not taxonomy or behavior.
So it's in the scorpionfish family.
Yeah.
It has venomous sting, not roar.
Exactly. And this little exchange becomes a neat lesson, framed in code terms, about the difference between a descriptive name, like a common name for an animal, chosen for looks or convention, and the actual underlying implementation or inheritance.
Like a misleading variable name in code. It looks like one thing but does another, or belongs somewhere unexpected. It highlights that programmer's instinct. Question names that don't seem to match the underlying logic or structure.
Precisely. But then the conversation takes this really sharp turn, completely away from animals.
Where does it go?
To metal cats.
Metal cats. Okay, is this some kind of weird hybrid creature? The source initially treats it like a possible bugged in the zoo's class hierarchy, right?
Yeah, like someone accidentally inherit feline into the heavy metal namespace. But no, it's quickly clarified. Metal Cats is a human metal band performing at the zoo.
Okay. That transition is actually really significant for our analysis, isn't it?
Hugely significant. It hammers home that strong link to modern life and culture, maybe even stronger than the link to nature. The user's world contains zoos and metal bands, and critically, they apply the exact same analytical framework to both.
The structure they use for a gorilla, they just immediately apply to a rock band.
Yep. We get a metal cat breakdown. Class metal cat presumably inherits from musician or performer, though it's not explicit. Attributes cover their role: guitarist, vocalist, energy level, outfit style. And methods are their actions: shred solo, headbang, growl vocals, throw horn sign.
Wow, okay. Applying class structure to a cultural phenomenon. A band member defined by role, state, and actions. It makes a weird kind of sense.
But this is where the user has that really clever programming-inspired moment of insight.
The shared functionality idea.
Yes. They suggest that the throw horn sign method shouldn't just be in the metal cat class. It should also be shared with the rhino class.
That's brilliant. From a developer's perspective, that's genius pattern recognition. Identifying a common behavior, making that horn shape, either with a hand or an actual horn, across two completely unrelated classes, an animal and a human performer.
Exactly. And the explanation dives into how you'd actually handle that in good object-oriented programming. You could just copy-paste the function into both classes, but that's bad practice code duplication.
Right. Not DRY, don't repeat yourself.
So the better way, as the source suggests, is to extract that shared behavior, maybe into a common interface they both implement, or even better, a mixin, like a horn sign mixin.
Can you quickly explain what a mixin does here, conversationally?
Sure. So unlike direct inheritance where, say, a gorilla is a type of primate, mixins are for when different classes just share a specific capability or behavior, but they aren't types of the same fundamental thing. A rhino isn't a metal cat. A metal cat isn't a rhino.
Right, totally different base classes.
But they can both perform the throw horn sign action. A mixin lets you define that action just once in the horn sign mixin, and then you can kind of bolt it onto or mix it into any class that needs it, like rhino and metal cat, without messing up their main inheritance lines.
Got it. So it's a way to share specific bits of functionality across unrelated things.
Yeah.
That's a really core programming pattern, isn't it? Code reuse, modeling shared behaviors.
Absolutely. And using rhinos and metal cats throwing horn signs is just a fantastic, funny, relatable way to illustrate that fundamental programming concept. It shows these ideas aren't just for computers, they're abstract tools for modeling relationships and behaviors in any system.
And the user spotting that connection, that abstract pattern between a rhino and a metal cat, that's peak programmer thinking right there.
This whole detour, from lionfish names to metal cat classes and rhino mixins, it just underlines how deep this technical lens goes for the user. They apply it everywhere, reinforcing that strong connection to modern technical ways of thinking.
So where does the conversation wrap up? Does it come back from the abstract?
It does. The final exchange brings this whole programming framework right back home, literally, to the user's immediate personal life.
How so?
They mention heading home with class, girlfriend, who apparently has called the bored and low energy methods. Or maybe those attributes are set to true.
Huh. Okay. Applying the class structure to their partner.
Yeah.
Bold move. And what's the fix for this state?
The proposed solution is wonderfully simple. Print, pork fried rice.
That's it?
That's it. But it's a perfect little example of applying basic programming logic to everyday life. The user identifies the state of the girlfriend object, she's bored, and low energy. The solution is basically an if-then statement.
If girlfriend.is bored and girlfriend.has low energy, execute provide food solution.
Food type, pork fried rice, something like that.
You gotta say if state X and state Y, then perform action Z. It's fundamental conditional logic. They identified the state, the conditions, and executed a defined action-making or ordering pork fried rice, which presumably resolves the bored and low-energy states. It perfectly shows how that programmer mindset, breaking things down into states, conditions, actions, gets applied outside of work, even to something as simple as figuring out dinner or cheering someone up. Structured thinking applied personally.
And this simple, funny closing example circles right back to one of our big questions. Can people think with programming logic even without a formal coding background?
Well, the user is a developer here, but the analogy itself, the girlfriend pork fried rice logic, is incredibly basic. It's just simple if-then.
And the whole conversation we've unpacked, structuring animals as classes, spotting shared methods between rhinos and metalheads, using simple logic for dinner plans, it uses these really relatable, non-technical examples to illustrate core programming ideas.
Classes, attributes, methods, inheritance, mixins for shared functions, conditional logic, all explained using gorillas, fish, bands, and relationships.
The source notes, particularly from that humorous deep dive guide, hinted this could actually motivate coding by showing it's maybe not that complicated, by framing complex biology or social stuff in these terms.
And showing how basic if-then applies to everyday problems.
It kind of implicitly argues that the thinking behind code isn't some alien skill set. It's a logical way of breaking things down, seeing connections, defining responses. It's structured problem solving.
So the perceived difficulty of coding might be less about the core logic, which seems pretty intuitive here, and more about, learning specific syntax, the tools, the sheer volume of libraries and frameworks.
Right, but the fundamental thinking, if you can follow the logic of if bored and tired, get takeout, you're already using the same kind of thinking that underlies programming. The humorous, accessible way these sources presented it makes the technical feel much more intuitive.
It bridges that gap, showing the programming framework isn't just for screens. It can be a lens for understanding life.
So wrapping this up, what did our deep dive into this programmer zoo trip really reveal? It's been this fascinating look at how we use frameworks, biological, cultural, or computational, to make sense of the world.
Yeah, we saw how applying programming concepts brought structure, clarity, and definitely a lot of humor to describing everything from gorillas to rock bands to relationships.
It certainly highlighted that interesting tension, maybe a slight detachment from pure nature for the tech immersed, but also the incredibly powerful, pervasive influence of modern technical thinking on how they see everything.
And it really challenged fixed ideas about complexity, didn't it? What's complicated to one person might be crystal clear to another using a different mental toolkit. Complexity seems relative, dependent on the framework you're using.
And maybe the most compelling takeaway, for me anyway, is seeing how naturally these core coding ideas, classes, methods, logic could be applied everywhere. It really suggests that the fundamental thinking behind coding might be more intuitive, more accessible than we often assume.
What really stood out to you from this deep dive? Any particular method or class definition?
Hmm. Well, here's a final thought to maybe debug on your own time. If thinking about a gorilla's behavior as a set of functions or solving a relationship snag with simple if-then logic can actually bring clarity or even just a laugh, what other complex parts of your world could you understand a bit better or approach differently by looking at them, just for a moment, a little bit more like a program?